Hi and welcome back. So in the last video, I hopefully gave you a little bit of an intuition as to maybe if you're in a chemistry class, maybe you've heard this term before, valence electrons. If you're not, I'm going to define the term, or I maybe did define the term a little bit, and I'll give you a bit more information as to how to find valence electrons in this video. But what we essentially did was I hopefully gave you a bit of intuition as to more or less what the valence electrons determine. And essentially, what they determine is how they are the electrons in a given element that are going to react. They are the electrons that are going to react with other atoms and determine, I guess we could say, the reactivity of certain elements. So now, in the last video, we said, and I started off saying that we did an electron configuration for neon. And then I changed my mind and I said, well, actually, let's just say that this atom is a fluorine atom instead. Because neon atoms, I've been telling you a lot, and hopefully in the next bunch of videos, I'll actually show you why neon is unreactive. But I've been saying that neon doesn't react. Neon does not like to react with other atoms. Fluorine, however, is extremely reactive. And the reason fluorine is extremely reactive is because of its valence electron configurations. And we're hopefully going to realize more about why fluorine is extremely reactive in this video. So anyway, one of the things that we did in the last video was we went over, we essentially drew these two diagrams of these different atoms and said, you know, when we move these together, more or less when I said when I moved these together, it was like I was reacting them, and I grabbed this one, and now a whole bunch of stuff is going to move on my page when I move it. But if I move that atom closer into the other one, if I move these two together, the outermost electrons are the ones that are going to essentially be reacting with each other. And you can also maybe imagine that because our nucleus has a positive charge and the entire rest of the atom has a negative charge, the outermost electrons are, I guess, going to experience that charge, that positive attractive force back into the nucleus, probably at least a little bit less than, or some amount less than the electrons that are really close into the nucleus, which will eventually we're going to start calling those the core electrons. But anyway, what I guess I want to show you is in the case of fluorine. In the case of fluorine, and this is in this depiction that we drew, we've got all of this in purple right here. So all of this orbital, that's this spherical shell orbital that we were talking about. This is our 2s orbital, and then all of these lobes that are also around there, I guess, in our 2s orbital. These are our 2p orbitals. So when our 2p electrons fill up their orbitals, the probability, you have the greatest probability of finding those electrons within these type of shapes, within these type of lobe-like shapes. And so and if you look at this depiction, and you know, you shouldn't go completely off of just something that I guess I drew. But essentially, one of the things that I guess you might realize, or one of the things I was trying to do when I drew this, was to show you that if these two were reacting, and if we were moving them together, it's really just going to be these two groups of electrons, our 2s2 and our 2p5 electrons, that are going to react. And essentially what we are going to find out in this video is that these electrons, so our 2s2 and our 2p5 electrons, are our valence electrons. These are our valence electrons for fluorine. These are our valence electrons. And actually, you know what? I'm going to clean up my canvas a little bit, and there we go. So we are going to have essentially the valence electrons that are going to be around our fluorine. So fluorine, we remember that fluorine's electron configuration is 1s2, 2s2, 2p5, and these electrons are going to be our valence electrons. And essentially what we're able to do is we're able to say for any s block, so over here is the s block, and if you remember from the electron configuration videos, I kind of edited my periodic table so that helium, instead of being all the way over here on the right, was actually over here right next to hydrogen, because helium, maybe I'll just do that. I'll say helium is right there. Helium is in the s block, and maybe I'll cross it out there. And then over here, so everything in the s block and also everything in the p block, what we are going to be able to say about the valence electrons for all of these elements, for all the elements in the s block and for all the elements in the p block, is that the number of valence electrons that we have, or the way we count valence electrons, is we take our highest period number. So our highest period for fluorine was a 2, and we add up all of the electrons that we have in that level, you could say, in our highest level. So let's just do an example. Let's take, fluorine is in the p block. Let's do an example from the s block. Let's take calcium. So calcium is down here. Let's number the periods. We have 1, 2, 3, 4. So calcium is in the 4th period, and we could do our entire electron configuration. Let's actually you know what? Yeah, let's do our entire electron configuration. So for calcium, we can say that this is 1s2, 2s2, 2p6, 3s2, 3p6, and then after 3p6, what do we have? Well, we have 4s2, right? And we're going to find out, because those are the only 4-level electrons. Those are the only electrons that I guess you could say we have in this 4th energy level. For calcium, these are going to be our valence. These are going to be our valence electrons. Let's do another one of these. I'll scroll up. Actually, you know what? Maybe I'll just scroll up a little bit. There we go. Okay, let's do sulfur. Let's do sulfur right here. So if we say for sulfur, what's our electron configuration? And I'll do the entire electron configuration. We've got 1s2, 2s2, 2p6. Then, actually, I'm going to change colors. Then we've got 3s2, and then 3p4, right? So now, which are going to be our valence electrons? And you can probably see that I've written them down in red, so they're probably pretty obvious. It's going to be these. I'm going to choose a different color to circle that. There we go. It's going to be these electrons, right? It's going to be these electrons because they're in our 3rd level. They're in the 3rd energy level. So therefore, if we said calcium, and we're going to find out that the most important thing about the valence electrons is really the number of valence electrons that we have. So calcium we figured out has 2 valence electrons. Sulfur has got 6. It's got 6 valence electrons. So actually, you know what? I think I am running low on time. In the next video, we're going to talk a little bit more about these valence electrons and how we can predict how many valence electrons we have in each row, and also maybe start talking about what the number of valence electrons that an atom might have might mean for the reactivity of that element. So anyway, thanks so much for watching, and I'll see you in the next video.